Hello students, welcome back to the math class. Today we are going to start from question number 5 of exercise 8.1. We have finished till question number 4. So let us see from the question number 5 onwards. In the question number 5 we have given that show that the diagonal of a quadrilaterals are equal and bisect each other at right angles, then it is a square. Means we have given that one quadrilateral in that the diagonals are bisecting each other at a right angle, means they are dividing into two equal parts. The one diagonal divide the another diagonal into two equal parts and they are perpendicular as well. Then we have to prove that it is a square. Remember, we have given the property of the diagonal of the square, so we have to prove the property of side and the angles. Okay, there are basically any special kind of quadrilateral, it's divided into three properties. One is side, about the side, about the angle, and about the diagonal. For example, if we talk about square, okay, so in square what is the property about the side? All sides are equal, the side opposite to each other are parallel. Okay, what about the property of angles? All angles are equal to 90 degree. And what is about the diagonal? Then diagonals are equal and they are bisecting each other at right angle. Okay, so see here, third property about the diagonal is given to us and we have to prove remaining two properties. Means we can say that if the third property is true, then the remaining two property will be also true and hence the figure will become a square. So we have to prove the remaining two properties of the square. One is all sides are equal and the all angles are equal to 90 degree. So here initially to prove that all sides are equal means we shall prove the given figure is a rhombus. First of all, as the figure you are looking over here, I will suppose this figure as name I will give as ABCD. This point is A, this point is B, similarly this is C and this one is D, and point of intersection I am supposing here as O. Okay, now what is given to us? Once again I repeat, diagonals are given equal, means AC and BD are given equal. They are bisecting each other, means we can say that the length of OB and OD are equal, length of OA and OC are equal, right? And they are bisecting each other at right angle, means at a point O the angle is going to form of 90 degree. And if angle AOD is of 90 degree, I have marked here AOD, doesn't mean that only angle AOD is of 90 degree. At a point O, whichever the angle you are looking, COD, BOC or AOB, that all angles will be are equal to 90 degree. Okay, so let us write down the given first. First of all, we shall see the given. In the given, we shall write down in quadrilateral, in a quadrilateral ABCD, what we have given to us? Diagonal. First of all, we shall talk about diagonal AC and BD are equal, comma, diagonal bisect each other at right angles. So we shall little bit explain this one. What is this property actually? Okay, means diagonals are bisecting each other means we can say that that is OB is equal to OD, comma, OA is equal to OC, and the value of any angle at a point O will be equal to 90 degree. So we can write down that one as angle AOB is equal to angle BOC is equal to angle COD is equal to angle AOD. This all four angles will be equal to 90 degree each. Now what we need to prove here, that we shall write down. So to prove, we have to prove that ABCD is a square. So we will write down here ABCD is a square, that we will prove it. Okay, now let us start the proof of the question. For doing this proof, I have again drawn two figures for you. That figures we shall use it in our proof. See, this figure is nothing. I have just taken a part of the given figure. So I am just taking a part of that. The part is taken. You observe the triangle DAB, I am taking it. If you compare, so this point is D, this is my A, and this one is B, and again this point is O. Observe, I have already marked OD and OB are equal, OA and OA common, and this angle AOD and angle AOB we have written already, they are 90 degree each. So with the help of side angle side theorem, easily these two triangles can be proved congruent. So first we shall write down in the proof, in triangle AOD and triangle AOB, these two triangles I am taking. You need to take care of one-to-one correspondence. I am also taking care, otherwise you can draw two rough triangle as we have drawn each and every time in the chapter number 7. Okay, so now these two triangles I am taking. First of all, we shall mention OB is equal to OD, from where we can say this is given in the question, one thing. Then second, OA is equal to OA, that is common. Third thing, angle AOD is equal to angle AOB, that is each 90 degree. Therefore, triangle AOD is congruent to triangle AOB. How we can say? By side angle side congruency rule. Okay, so remember we have taken two side and one angle, so that's why side angle side is applicable. If you see properly, the angle is coming included between the two sides, so that particular rule is applicable. Now if these two triangles are congruent, then you observe the figure, side AD is equal to side AB, that is with the help of CPC, that we can see. Okay, if you draw the two triangles roughly over here and make one-to-one correspondence, then these two sides will be coming as a third pair of corresponding side. Already two pair of corresponding sides are equal, then only we are able to prove the triangles are congruent. So whichever the third pair will remain, that is AB and AD, that will be also congruent, because that will be also equal, because triangles are congruent. Okay, so now see, AD and AB I have proved equal. Now try to remember similar kind of questions I have explained you. In that we have seen the question, first of all we have proved AD and AB are equal. In the similar way we can prove it AB and BC are equal. Then again in the similar way BC and CD equal, CD and DA equal, and ultimately we can conclude all four sides are equal. So exactly same thing we shall do it here. We shall conclude all the four sides are equal, and in a quadrilateral all four sides are equal, then we can say that it is a rhombus. So basically our quadrilateral will become a rhombus. Further we shall prove it, it is a square. Okay, so let us see first how we can complete till rhombus. So here first we shall write down in the solution, first we shall write down further. Similarly we can show that. Similarly, what we can show, the side AB can be equal to BC, then BC can be equal to CD and CD can be equal to AD. This I am giving to us equation number 2, 3 and then 4. Okay, so now we can conclude all the 4 equations. You can see AD and AB are equal, AB and BC are equal, BC and CD are equal, and CD is again equal to AD. So if you conclude, all 4 sides are becoming equal. Okay, so we can say that therefore by equation number 1, 2, 3 and 4 from one, 2, 3 and 4. Okay, 1, 2, 3 and 4. Now here we can conclude that AB is equal to BC is equal to CD is equal to DA. So we can say that hence ABCD is a rhombus. Hence ABCD is a rhombus. Okay, so first of all, see what we have proved. The given figure is a rhombus. Now further we need to prove the given figure is a square. So difference between rhombus and a square. What is the basic difference? The basic difference between a rhombus and a square is about the angles. If all angles of a rhombus becomes 90 degree, then automatically it will be also called as square. So here further we need to prove that the given figure has all angles are equal to 90 degree. Now see, our figure is looking like as a rhombus because we have proved all sides are equal. Now again I am taking 2 triangles. As you can see the figure I have drawn here. This figure we can take it little downside first of all, and we can give the name. This figure is a complete figure I have taken, only I have not drawn the side coming at the top. Okay, so once again I will take this figure downside. Yes, and let us give the name over here. First I am giving the name of this figure as this point is A, this is my point is B, this point is C, and this point is D. Only I have not joined CD over here, and I am not marking the point O. Okay, now here we are going to prove that angle A and angle B is equal to 90 degree, and in the similar basis we shall prove it angle C and angle D will be also equal to 90 degree, and hence we can say that all 4 angles will be 90 degree. Now you see in this figure AD and BC are equal, just now we have proved. Okay, AB common, that is common in both the triangles. I am going to take a triangle here DAB and CBA. These 2 triangles I am taking. And the third thing is the diagonals are equal. AC and BD are given equal. So here third side AC and BD we shall get equal. So now we shall write down, now consider triangle DAB and triangle CBA. These 2 triangles I am taking. Okay, now in these 2 triangles, first of all you see AD is equal to BC. You can write down proved earlier, or you can write down ABCD is a rhombus. Since ABCD is a rhombus, all sides are equal. So ABCD is a rhombus. That is our reason here. Second thing, AB is equal to AB, common. Right? Now further the third thing, AC is equal to BD. That I am using a different one. AC and BD are equal because it is given to us in the question. We have mentioned in the question as well. So now we can say that therefore triangle DAB is congruent to triangle CBA, that is by side rule. Okay, and if these two triangles are becoming congruent, then definitely again with the help of CPCT we shall get some parts of the triangles will be equal. So here we shall get angle DAB is equal to angle CBA. DAB and CBA are equal, that is with the help of CPCT. Now if you look carefully, DAB is actually angle A and CBA can be written as angle B. Both the angles are equal. I am supposing equal to X. And one more thing you observe here, since we have proved that AD and BC are equal, we have proved that ABCD is a rhombus, so AD and BC are parallel. Look at the main figure ABCD where we have proved rhombus. So AD and BC we can say that equal, as well as they are parallel also, because now the figure is a rhombus. Okay, so angle A and angle B, if we talk about, if AD and BC are parallel, then what is angle A and angle B here? Angle A and angle B are the interior angles and hence they will be supplementary. Okay, that we can say. So here that things only we shall mention. Now further we'll write down, since AD is parallel to BC, therefore angle A plus angle B is equal to 180 degree. Here reason can be given interior angles, which implies that angle A will be equal to X, angle B will be equal to X, and then is equal to 180 degree, because angle A and angle B both are equal. So which implies that this will be 2x is equal to 180. Now from 2 if we cancel 180, that is 90. So therefore value of x is 90 degree and x is 90. So therefore we can say angle A is equal to angle B is equal to 90 degree. And similarly we can show angle C and angle D will be also 90 degree. Similarly angle C would be equal to angle D would be equal to 90 degree. Therefore now we can say that ABCD is a square, because see already it is rhombus and we have proved all angles are equal to 90 degree. So we can say that ABCD now become as a square. So ABCD is a square, that we can say now, because if a quadrilateral have all sides are equal and all angles are equal to 90 degree, it will be square. Now let us see the next question, question number 6. Now see, in the question number 6 what we have given to us. See, in the 6th question we have given that diagonal AC of a parallelogram ABCD bisect angle A. First of all, meaning should be clear. Bisect angle A means what? Bisecting of angle means it divide the angle into two equal parts. So for example, suppose if I say this is angle A and this is one part of angle 1 and this is another part of angle 1, means angle 1 and angle 2 are the two part of angle A. Okay, so here we can say that these two parts are equal, same. Okay, so here that is the one thing we have given, that ABCD we have given as a parallelogram. Then we have to prove that it bisect angle C also. So if I take the part of angle C, means if I say this is angle number 3 and this is angle number 4, so I have to prove here angle 3 and angle 4 are equal. Second thing I have to prove, ABCD is a rhombus. See, to prove a parallelogram as a rhombus, only one thing is required to prove. In parallelogram, only side opposite to each other are equal, while in rhombus, all sides are equal. Okay, so here we have to prove that all sides are equal. Now to prove that all sides are equal, it is not required to prove each and every side we are proving equal. See, already two sides are equal. Okay, so the sides, suppose AB and CD, if I talk about, so AB and CD already equal, BC and AD are already equal. So if I able to prove any two adjacent sides are equal, for example AB and BC, then I can say that since AB and BC are equal, AB and AD will be also equal, because BC and CD are equal, and BC and CD will be also equal. So we can say that all four sides will be equal if I am able to prove any adjacent pair, one adjacent pair of the sides will be equal. So let us see first and second part one by one. First of all, we shall write down the given things over here. In the given, first we will mention ABCD is a parallelogram. And we can say that angle 1 is equal to angle 2, because it is given to us, it bisect angle A. So we are supposing 1 and 2 are equal. Now what we have to prove? To prove first part. See, in the first part you observe what they are saying, it bisect angle C, means in the first part we shall prove angle 3 is equal to angle 4. And second part, we have to prove that ABCD is a rhombus. So now we shall write down ABCD is a rhombus. Okay, now further let us see the proof. So in the proof, first of all, we'll write down, since we have, see, we have given that already angle 1 is equal to angle 2. This is my equation number 1. Okay, and ABCD is what actually? ABCD is parallelogram, that is also given in the question. ABCD is a parallelogram, and we know that in a parallelogram side opposite to each other are parallel. So AB and CD will be parallel over here. So we shall write down further, AB is parallel to CD. Okay, now look at carefully the side AB and CD. AB and CD are parallel, and if I ask you what can you say about the angle 2 and angle 3? Observe carefully, angle 2 and angle 3, if you see carefully, they are forming the letter Z. Observe it. I will try to draw the line from D, then once again if I draw from here, this is the line CD, then C, this is your diagonal. If I am able to draw it correctly, observe, oh sorry, this is not possible to draw exactly on over here, but see, this is the side, you see it carefully, and this is your angle 2 and this is your angle 3. So observe, angle 2 and angle 3 are forming the letter Z onto the side AB and CD, where AC is the transversal. Okay, so we can say that here angle 2 and angle 3 are alternate angle. And if we talk about in the same manner, AD and BC are also parallel, because it is a parallelogram. So another pair will be also parallel, and hence angle 1 and angle 4 are also alternate angle, and these alternate angles are equal because lines are parallel. Okay, so here first we will mention AB is parallel to CD, therefore we can say that angle 2 is equal to angle 3. Reason can be given alternate angles, and this can be equation number 2. Okay, and we can write down, and AD is also parallel to BC. So therefore we can say angle 1 is equal to angle 4. Equation number 3rd. Reason will be same, alternate angles. Now look at the equation number 1, 2 and 3. Observe, angle 1 and angle 2 are equal. So we can say that the left hand side of equation number 2 and equation number 3 will be same. And we know that if any two equation left hand sides are equal, then right hand side will be also equal. So what is the right hand side of equation 2 and 3? Angle 3 and angle 4. So we can say that angle 3 and angle 4 are also equal. So here we can write down by equation first, second and third, we can say angle 3 is equal to angle 4, and angle 3 and angle 4 are equal means we can say that we got the answer of part number 1. That we shall write down properly. Diagonal AC bisect angle C also. Okay, here you can mention proved first part got over. Now let us see the second part. In the second part, what they are saying, prove that ABCD is a rhombus, means we have to show that all sides are equal. As I have told you, since already it is a parallelogram, to prove a parallelogram as rhombus, we need to prove only one pair of adjacent sides are equal. Means you take AB and BC. AB and BC will be called as the adjacent side. Adjacent side means those sides which have one common vertex. For example, between AB and BC, you observe B vertex is a common, or you can take such kind of any other pair. Okay, so now how we can prove it? We will take here, first of all, you observe we have three equations. Angle 1 and angle 2 are equal, and angle 2 and angle 3 are equal. So if I take the first two equations, so see 1 is equal to 2 and 2 is equal to 3. So we can say that 1 and 3 will be also equal here. Okay, because angle 2 is common between them. So if I take equation number 1 and 2, so I can say that now by equation first and second, by equation first and second, angle 1 is equal to angle 2 and angle 2 is equal to angle 3. So I can say that angle 1 will be equal to angle 3. Now you know that one theorem which maybe you forgot, so I will draw the figure over here to explain your theorem once again. Suppose I have a triangle PQR, and if I say in triangle PQR angle Q and angle R are equal. Okay, angle Q and angle R are equal. So we know that the side opposite to angle Q and R will be also equal. Which side is opposite to angle Q? That is PR. And which side is opposite to angle R? That is PQ. So PQ and PR will be also equal. This theorem is called as the converse of isosceles triangle theorem. Isosceles triangle theorem says if two sides are equal, then the angle opposite to them are also equal. Here we are using the converse. If two angles are equal in a triangle, then side opposite to them will be also equal. Now look at the side opposite to angle 1 and angle 3. Remember, you have to see a triangle ADC. ADC. Angle 1 is opposite to which side? Observe it carefully. Angle 1 is opposite to the side CD. Okay, and similarly angle 3 is opposite to side AD. So AD and CD will be equal. And what I said to you earlier, prove any one adjacent pair is equal. So AD and CD are adjacent pair and we have proved it. So we can say that ABCD is a rhombus. Okay, so here we shall write down further. Therefore AD is equal to CD. Reason can be given, side opposite to equal angles. Side opposite to equal angles. Okay, that we will mention here, side opposite to equal angles, and hence we can say that therefore ABCD is a rhombus, because whichever the side was unequal, that also we have proved equal. AD and CD are equal, then AD is already equal to BC, so CD will be also equal to BC, and CD is equal to AB, so AD and AB and BC will be also equal to, that means ultimately all four sides are equal. So hence we can say that all four sides are equal, it will be a rhombus. So this way we have completed the question number 6th. Last question we'll do of today, that is question number 7th. Quickly we'll try to finish it. Okay, this question is actually lengthy, but I will try to solve as short as possible. See, in the 7th question we have given that ABCD is a rhombus. Show that the diagonal AC bisect angle A as well as angle C, and diagonal BD bisect angle B as well as angle D. So diagonal BD bisect angle B as well as angle D, that we can show it similarly, means we need not to prove it again and again. But here diagonal AC bisect angle A as well as angle C, that we can prove it clearly. How we will show that? Okay, so first of all, see, we have given that one figure ABCD is a rhombus and it is bisecting angle A. We have to show that it is bisecting the angle A as well as angle C. So here I am marking angle 1 and here I am marking angle 2. Okay, and we need to show that angle 1 and angle 2 are equal. Okay, and here for my convenience right now I am marking as angle 3 and angle 4. So first we shall write down the given things over here. What is given to us? ABCD is a rhombus. That is the only one thing is given in the question. So properties of rhombus will be applicable here. Okay, to prove, what we have to prove? That first part, diagonal AC bisect angle A comma angle C both. Second part, diagonal BD bisect angle B comma angle D. Okay, so let us see how we can prove it. First of all, in the proof, first part I am going to prove diagonal AC bisect angle A over here, means we shall prove that angle 1 and angle 2 are equal. Okay, so first I am taking here, since ABCD is a rhombus, we have given that ABCD is a rhombus. Okay, and in rhombus we know that all sides are equal and side opposite to each other are always parallel. So here we can say that therefore AB is parallel to CD. And if AB and CD are parallel, it means that angle 2 and angle 3 will be equal. That also we can say angle 2 is equal to angle 3. How we can say? Because these are alternate angles. Alternate angles will be equal if lines are parallel. So AB and CD are given equal, so angle 2 and angle 3 are equal over there. Now we shall take a triangle ADC. Now in triangle ADC, see, in triangle ADC, one thing I am writing here, AD is equal to CD. How we can say that? Since ABCD is a rhombus, all sides are equal. ABCD is a rhombus and hence all sides are equal there. Right? Now if AD and CD are equal, we know that just now we have done one theorem. The name of theorem is isosceles triangle theorem. So in that we have seen if two sides are equal in a triangle, then angle opposite to them are also equal. So see, basically we have AD and CD are equal. In front of AD you observe angle 3 is coming, and in front of CD you observe angle 1 is coming. Remember, I am taking only triangle ADC. So angle 1 and angle 3 are equal with the help of isosceles triangle theorem. So which implies that angle 1 is equal to angle 3. Here reason we can give angles opposite to equal sides. 1 minute. Angle opposite to equal sides. Okay, this is angle 2 is equal to angle 3, equation number 1, and angle 1 is equal to angle 2, this is equation number 2. Observe, both the equation have same right hand side, so they will have the same left side as well. So by equation 1 and 2, I can say that angle 1 is equal to angle 2, and angle 1 and angle 2 are equal, so we can say therefore diagonal AC bisects angle A. Similarly, we can say that we can prove diagonal AC bisect angle C also. See if how we can prove similarly. Observe, I have taken all the angles along with angle A only. Okay, now suppose if I consider angle 3, angle 4 and angle 2. So angle 2 and angle 3 are equal because they are alternate angles, and angle 2 and angle 4 are also equal because AB and BC are equal. So if we apply the isosceles triangle theorem, so angle 2 and angle 4 will be also equal. 2 and 4 are equal, 2 and 3 are equal, so ultimately 3 and 4 will be also equal if we follow the same pattern as we have followed. So we can prove that diagonal AC bisect angle C as well. Now see, we have to prove second part, diagonal BD bisect angle B as well as angle D. So as you can see in the figure, we have just joined only diagonal AC, we have not joined BD over there. Now if I rub AC, means if I remove all the angles 1, 2, 3 and 4, and if I only join BD and following the same pattern exactly, I can prove it, the diagonal BD bisecting angle B and angle D. So here we shall mention, by following the same pattern, by following the same pattern, we can prove it in a similar manner that diagonal BD bisect angle B and angle D. Okay, so here second part can be proved in a similar manner. So today we have finished till question number 7. We can start question number 8 onwards next time. Thank you.